Hi everyone, in today's lesson we're going to talk about solving exponential equations, or in other words, finding common bases. So first off, what is an exponential equation? An exponential equation is an equation that contains a power with a variable for an exponent. Okay, so if I'm trying to solve for a variable that is in the exponent. So for example, 2 to the 2x equals 8 is an exponential equation because there's a variable in the exponent. Same thing with 5 to the x minus 1 equals 0.04. So this is the general concept that you need to know, that if b to the n is equal to b to the m, then the powers are equal. Basically, in other words, this is saying if the bases are equal, then the powers have to be equal. Like what? So let's do a basic example. Say I say 5 is my base, and 2 is my power, and then I say 5 is my base again, and then m is my power. So the only difference between this problem and this problem is that I made n equal to 2. So doesn't it make sense that m is equal to 2? Because 5 squared is 25, right? So 25 is equal to 5 to the m power. So basically, 5 to what power gives me 25? You should be telling me 2. So m is equal to 2. Now you don't have to show any of that work. Once you see that the bases are equal, 5 and 5, then you honestly just set the exponents equal to each other. So you would just say 2 equals m, and we're good to go. So that is what we are going to do when we solve all these equations, is we're going to find a common base and then set the exponents equal to each other. So the way that we do this requires a lot of rewriting regular numbers. So let's look at this table that I've made down here. I'm basically saying rewrite each number as b to some power, so as a base to a power. So for example, 4. 4 is a number that I can rewrite as 2 to the second power. Okay, how about 8? 8 is also another number that I could write using a base of 2. 2 to the third power will give me 8. How about 9? Is there a number that you could use to rewrite 9? I'm thinking 3. 3 to the second power. Okay, how about 16? Well, 16 you should be saying is the same thing as 4 squared. But 16 is one of those unique numbers that actually you can use a different base. How about if you did 2 to the fourth power? If you don't believe me, put 2 to the fourth into the calculator and you'll get 16. Okay, how about 25? 25 we all know as 5 squared. 27 we all should know as 3 to the third. 32 is the same thing as 2 to the fifth. And 64 has a few of them. 64 is the same thing as saying 8 squared. Also the same thing as saying 4 to the third or 2 to the sixth power. There are 3 ways to write 64. Again, if you don't believe me, put them all into the calculator to see. 81 is the same thing as saying 9 squared or 3 to the fourth power. Now, these numbers up top, these whole numbers, are going to be the bases that you're going to have to rewrite using these bases down here. So it'll help if you memorize some of these or at least understand most of them so that you can use them. The harder ones that you're going to have to rewrite are going to be the fractions. So if I want to rewrite each fraction as a whole number to an x power, how would I do that? Well, it can be done relatively easily. The first thing you always want to do is recognize that every single one of these fractions on the denominator, it's really 4 to the first, 8 to the first, 9 to the first. So every number in the denominator of these fractions is a whole number raised to the first power. And the first and foremost way to make this thing a whole number is by taking this power that's down here in the denominator and bringing it upstairs each time. Bring each one upstairs. So remember, whenever I move an exponent, it becomes positive or negative. So this is really the same thing as saying 4 to the negative 1 if I bring it up. So is this 8 to the negative 1. 9 to the negative 1, 16 to the negative 1, 25 to the negative 1, 27, 32, 64, and 81. So I remember we spoke about making them positive. If it's negative, you bring it to the denominator to make it positive, hence this. So you can go the reverse way, that if it is positive, you can bring it up to make it negative. So now you can rewrite these bases just like you did before, where 4 is the same thing as saying 2 squared, and you want to raise that to the negative 1 power. So all I did was rewrite the 4 as 2 squared, and I'm raising it to the negative 1. So this 1/4 is the same thing as actually 2 to the negative 1. How'd I get that? Because I multiplied the 2 times the negative 1. When I raise a power to a power, I multiply. Okay, how about 8? We said 8 was the same thing as saying 2 to the 3rd, and I'm going to raise that to the negative 1 power. So when I multiply 3 and negative 1, I get 2 to the negative 3rd power. Okay, how about 9? 9 was the same thing as 3 squared. Raise it to the negative 1 power, and I'll get 3 to the negative 2. Okay, 16, we could write this 2 ways. We know that 16 is the same thing as saying 4 squared, or it's the same thing as saying 2 to the 4th. So again, I took 16 and rewrote it as 4 squared, then raised it to the negative 1 power. So there are 2 answers for 16. 4 to the negative 2 and 2 to the negative 4. Okay? See if you can do the rest of the chart. Pause the video until you've done so and then hit resume for your answers. Okay, so for 25, you should have gotten 5 squared to the negative 1, or 5 to the negative 2. 3 to the 3rd is 27, so 3 to the negative 3. 32 is 2 to the 5th to the negative 1, so 2 to the negative 5. 64, there were 3 answers. 8 squared to the negative 1, so 8 to the negative 2. 4 to the 3rd to the negative 1, or 4 to the negative 3. And the last one is 2 to the 6th to the negative 1, so 2 to the negative 6. 81, there was 2 answers. 9 squared to the negative 1, so 9 to the negative 2. Or 3 to the 4th to the negative 1, which is 3 to the negative 4 power. Okay, now let's put this all into play and actually answer some questions now. Okay, so the first problem, nice and easy. The bases are the same, so since the bases are the same, we can conclude that 2 must equal x. Some people like to cross off the denominators, it makes it easier to see. Excuse me, not denominators, bases. If the bases are the same, they cross them off and set the exponents equal to each other. And a check would be simple as solving by rewriting the original equation and substituting my value for x. X is 2, 25 equals 25. Done. Okay, so number 2. I cannot cross off the bases because they are not equal, so I need to rewrite them. It looks, though, from what we did before, that I could rewrite 8. I know that 8 is the same thing as saying 2 to the 3rd power. So now I have 2 to the 3rd equals 2 to the 2x. Are my bases equal? Yep. So you can cross them off and say my final answer would be 2x equals 3. So I set the exponents equal. Divide both sides by 2. X equals 3 halves. Okay, so the check. 2 to the 2x equals 8. 2 to the 2 times 3 halves equals 8. These cancel. So 2 to the 3rd, that definitely equals 8. So we're good to go. Okay, how about example number 3? If you notice on example number 3, we're going to actually have to change both of the bases, because there's no way that I could rewrite 8 with a base of 4. If I did 4 squared, I get 16, not 8. So we know from the other example that 8 is the same thing as saying 2 to the 3rd. And we know that 4 is the same thing as saying 2 squared. And now these things need to be raised to the powers that they originally came from. Okay, now before we can cancel out the bases, we actually have to get rid of these parentheses. So we're going to multiply the 2 and the 2a, and we're going to multiply 3 into all this. Or in other words, multiply 3 times a, which gives me 3a, and 3 times 1, which gives me 3. Okay, now the bases are the same, so I can cross them off, and I can set the exponents equal to each other. So 2a equals 3a plus 3. Solve for a by subtracting 3a on both sides. So we get negative a equals 3. Divide everything by negative 1, and we get a equals negative 3. Now I'm not going to do the checks for these, but I do expect that all these checks will be finished for tomorrow. Okay, so number 4. As we can tell, the bases are identical already. So you know what to do. Cross the bases off and set the exponents equal. So x squared plus 2 equals 6. Okay, anytime we want to solve an equation that has an x squared in it, we have to get it equal to 0. So we get x squared minus 4 equals 0. Factor using dots. And then my final answer is x equals negative 2 and x equals positive 2. So again, check them out. Both will work. Okay, the last two examples have fractions. So the first thing that you want to do is bring up this power of 2 to the first. So make it 2 to the negative 1. Remember we talked about that in the other slide, that I could take this, bring it upstairs, and make it negative. And I want to raise this to the x power. So if you can tell, I basically rewrote 1/2 with a base of 2, so I should probably do the same thing with 8. I could rewrite 8 with a base of 2, so 2 to the third to the 2 minus x, and then I can distribute these powers in. So negative 1 times x is negative x. 3 times 2 is 6. So 2 to the 6 minus 3x. Now I have the same bases. I can cross them off. So negative x equals 6 minus 3x. Add 3x on both sides. I get 2x equals 6. Divide by 2. X is equal to 3. Alright, why don't you try number 8 by yourselves? Hit resume when you're finished. Okay, here's your answer. You first need to write this 1/3 as 3 to the negative 1. I want to raise that to the 1 minus x power. And I'm going to rewrite 9 with a base of 2. 3. 3 squared to the x power. Then I distribute this into both pieces. So 3 to the negative 1 plus x equals 3 to the 2x. Cross off the like bases. Negative 1 plus x equals 2x. Minus x on both sides. X is equal to negative 1. Awesome. Alright, so that's it on common bases. Jot down any questions that you might have, and please make sure that you finish all 4 checks before you come into class tomorrow. Have a good night.